Alright, so for this equation, I have a to the power of x plus a to the power of 1 minus x is equal to 10. Now my only variable in this equation is x, so that's the variable I'm going to be solving for. And now for the solution part, I'm going to first start by rewriting my equation over here so we have more space to solve it. So my equation is 8 to the power of x plus 8 to the power of 1 minus x is equal to 10. Now, if I have something in the form a to the power of m minus n, this is equal to a to the power of m over a to the power of n. So in this case, I have a to the power of 1 minus x, and I can rewrite that as a to the power of 1 over a to the power of x. Now, a to the power of x plus 8 over 1, a to the power of 1 over a to the power of x, what I'm going to do is I'm going to add these two as fractions. So to add these two, I'm pretty sure all of you guys watching this video probably know how to add fractions, but we multiply the denominators. So I have a to the power of x as a denominator, then a to the power of x times a to the power of x is a to the power of x squared, plus a to the power of 1 times 1 is just 8. So I have 8 to the power of x squared plus 8 over 8 to the power of x. And all of this is equal to 10. Now I'm going to multiply both sides by 8 to the power of x. So then these two cancel out, and I get 8 to the power of x squared plus 8 is equal to 10 times 8 to the power of x. Now, since we have two 8 to the power of x's over here, what I'm going to do is I'm going to let the variable u equal a to the power of x. So now if I substitute in u for a to the power of x, I get u squared plus 8 is equal to 10u. And now I'm going to subtract 10u on both sides. So then these two cancel out, and I get u squared minus 10u plus 8 is equal to 0. Now to solve a quadratic equation like this, I'm going to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is negative 10, and c is 8. So I get u is equal to negative of negative 10 plus or minus the square root of negative 10 squared minus 4 times a, which is 1, times c, which is 8, all over 2a, so 2 times 1. And now this is equal to positive 10 plus or minus the square root of 10 squared, which is 100, minus 32, all over 2. And now this is equal to 10 plus or minus the square root of 68 over 2. Now I'm going to simplify this a little more. The square root of 68 is equal to the square root of 34 times 2, which is equal to the square root of 17 times 2 times 2, which is equal to the square root of 17 times 4. And the square root of 17 times 4 is the same thing as the square root of 17 times the square root of 4, which is equal to 2 root 17. So I get u is equal to 10 plus or minus 2 root 17 over 2. And if I divide 10 with 2, I get 5 plus or minus, these two cancel out, the square root of 17. So now going back, remember how we let u equal a to the power of x. So now I have a to the power of x is equal to 5 plus the square root of 17. A to the power of x is equal to 5 minus the square root of 17. a to the power of x is equal to 5 minus the square root of 16, what I'm going to do is I'm going to take the log on both sides. So I get log a to the power of x is equal to log of 5 minus the square root of 17. And now if I have something in the form log a to the power of b, I can move this exponent and b to the front, so it's going to equal b times log a. In this case, I have log a to the power of x, and I can move x to the front. So I get x times log a is equal to log of 5 minus the square root of 17. And now I'm going to divide both sides by log 8. So then these two cancel out, and I get x is equal to log of 5 minus square root of 17 over log 8. And this can also be used for equation 1, the same method. So this is going to be log 5 plus or minus the square root of 17 over log 8. So these are my two solutions for x.